Okay. How was everybody this morning? So this will not take long. We just got a couple more slides to go through to finish chapter 14. And then I will go over the signature assignment, and y'all can start on your signature assignment. I've got them all printed up and ready to go. It shouldn't be too bad. It's going to take a little thinking, a little explaining, but it's not going to be too bad. So I think this is roughly where we left off yesterday. We're Texans, so we know the difference between tornado watch and a tornado warning. A watch, there is no tornado, but there's storms that could possibly produce tornadoes. So it's just to alert you and let you know that today's a possible tornado day, and to keep an eye out for anything that looks tornado-y. A tornado warning, someone has actually spotted a tornado. And you might even note, if you watch the weather when we have tornadoes, the weather people seeing a rotation on the radar is not enough to issue a tornado warning. Someone on the ground literally has to see it. They have to have some sort of eyewitness account that a tornado has not only formed but has touched down. Then they put out the tornado warning, I believe. And so we do use Doppler radar to help kind of put the weather watchers in the right place. But until they actually see the funnel cloud forming, they do not issue a tornado warning. But once they do, you know that there is a legitimate tornado, and it is possibly headed your way if you're in the path. So why do tornadoes have such high wind speeds? It's the difference in pressure. Inside the tornado, you have extremely low pressures, and so the winds are moving very quickly to get to that low pressure point. And as they spin around that vortex, they build up quite a bit of speed. And so it's the extreme pressure differences that allow tornadoes to get such high wind speeds. Then they get to hurricanes. And we don't get hit by hurricanes here, but we see them on the weather often enough because part of our state attaches to the Gulf, and we're not too far away from the hurricane states that get hit pretty often. So, no, to be called a hurricane, you have to be greater than 74 mile per hour winds. Before that, you're going to be a tropical storm or tropical depression. But once you get up to 74 miles per hour, you can start to be classified as a hurricane, and it goes up from there. They normally form between 5 degrees and 20 degree latitudes. So not at the equator and not too far away from the equator is usually where they form. Wind speeds can reach up to 300 kilometers per hour. They can generate very large waves, 50-foot waves at sea. And as we know from experiencing hurricanes a couple times, the storm surge can also be a big part of it, how much water it pushes up onto land right when it arrives. In the Western Pacific, they call their hurricanes typhoons. In the Indian Ocean, they call them cyclones. Not to be confused with the cyclones and anticyclones that are the high and low pressure systems that we discussed earlier. This is just a same name for a different weather function kind of issue here. So the North Pacific does have the greatest number per year. Good thing for the United States, we don't get any hurricanes from the North Pacific. So you can see the hurricane map right here. The vast majority of hurricanes we get come from the Atlantic. Note that right at the equator, you have almost no hurricanes form there. And there's almost no hurricanes. There's a couple every once in a while, but very, very few hurricanes cross over the equator from north to south. Because if you think about it, the Coriolis effect is causing them to spin in opposite directions. So in the northern hemisphere, our hurricanes spin counterclockwise because they're a low pressure center. They're going to spin counterclockwise. In the southern hemisphere, they're going to spin clockwise. So if you cross over the equator as a hurricane, the Coriolis effect is now acting in the opposite direction that it was before, and it starts to destabilize your hurricane. So very rarely do they cross over, and I believe when they do cross over, they usually don't last for very long. So that being said, you can see all of our hurricanes, not earthquakes, hit the eastern seaboard and the Gulf of Mexico because they're coming up from the Atlantic, the southern Atlantic Ocean, and heading towards us. We do get hurricanes that form near us in the Pacific, they just don't head to the United States. They head further out into the Pacific Ocean. Um, you almost never hear about California or Washington or Oregon getting hit by hurricanes. It's just not a thing that happens very often. So they do get a lot of hurricanes in the Pacific Ocean, especially over here towards the Philippines and in the Indian Ocean, heading up towards India as typhoons. Also, a lot that head towards Australia, apparently. But yeah, that's where your hurricanes form and kind of the direction they head from the places that they form at. This breaks down the different parts of the hurricane. We've all heard about the eye of the hurricane and the eye wall. It's the very low pressure system kind of inside that swirling vortex. And if you're in the eye of the hurricane, everything is apparently pretty calm. And it kind of seem like the storm's over, but really it's all around you. This is a fairly interesting chart. It shows pressure and wind speed. So the pressure is the orange line, the wind speed is the red line, and they're just kind of showing you as you get closer to the center of the hurricane, your pressure just drops and drops and drops and drops. As your pressure is dropping, your wind speed is rising. And so that's why, again, why tornadoes also have high wind speeds. It's that really low pressure at the center, which causes all the wind to rush into that vortex. And so the lower the pressure, the higher the wind speed. And then you get to the eye of the hurricane, which has the lowest pressure, but the wind speed also dies down because you're right in the center of the eye. And then it comes back up. So that's a pretty interesting chart right there as a hurricane passes over you. Just a couple more slides left. Hurricane formation and decay. So hurricanes are all going to form in tropical waters except the South Atlantic and East South Pacific. They need energy. They need that warm water to feed them energy to continue their motion. So energy from condensing water vapor is what they require. And you can see once they get over land and they don't have those warm waters to keep them energized, they start to degrade and kind of break apart. They develop most often in the late summer. That's the hurricane season. If they're really slow, 38 mile per hour winds or less, it's a tropical depression. If they get in between 38 and 74, they become a tropical storm. And then if they get above that, they're a hurricane. Also this year, you may have noticed, did y'all hear about Hurricane Iota? And I think there was a Hurricane Beta. We ran out of names this year. So they go through the alphabet. If you have an A named hurricane, it's the first hurricane of the season. And they literally go through the alphabet and pick out names. They started doing this I don't remember when they started doing this. I was going to say not too long ago, but I don't really know. But they started doing this because people weren't taking hurricanes seriously. So apparently, if you put a name to it and call it like a name and say, this thing is coming for you, people take it a little bit more seriously and kind of heed your warnings. So we've been naming hurricanes for quite a while now. And I think only a handful of times or maybe less, we have gone through all the names through Z and had to go to what is apparently the backup is the Greek alphabet. So alpha, beta, I don't know all the Greek alphabet. Obviously delta and kappa, and then iota is what we got to this year. Yeah, if we run out of regular alphabet names, we go to the Greek alphabet after that. So what do we have hit Houston? Harvey. So that was, kind of early in the hurricane season. H is not too late in the alphabet. Sandy would have been later as an S. I'm trying to think of other hurricanes that I know. Katrina, up near H at the not very beginning, but So if you recognize that, you can be like, it's kind of early in the hurricane season, or we haven't had very many hurricanes this year, or if you get to the end and you have Hurricane Terry or Teresa or something. Do we have a Hurricane Teresa? Maybe, I don't know. But if you got a T or U or V, we've had a lot of hurricanes in that season, and they've gone through the list. So the reason you get a lot of hurricanes forming in this area, this is where our hurricanes form and come up here, is because of those high surface temperatures. There's a lot of energy there that feeds the hurricane and makes the system stronger. So they diminish in intensity and start to break apart as they move over colder water or they move onto land. They're going to lose that energy source and not have enough energy to continue to spin in the way that they do. Large scale flow aloft is unfavorable for them. They got to have somewhere for all that air to go. Hurricane destruction, factors that affect the amount of hurricane damage. Obviously, the strength of the storm, how fast the winds are moving, the size and population density of the area. If they're an area that doesn't have anybody and we haven't built anything, then there's not a lot of destruction. Some trees get knocked over and we're not that worried about it. Shape of the ocean bottom near the shore. This is actually very important. The shape of the ocean bottom is going to determine how much water gets pushed onto land. Obviously, the amount of rain is a big deal, but that storm surge that the winds from the hurricane literally push up onto the beach can cause the most amount of your flooding. So the shape of the ocean bottom as it comes ashore is a big deal. The Saffir-Simpson scale ranks the relative intensity of hurricanes. This is probably Florida, seeing as I can see ocean on this side and on that side, although it could be like a barrier island kind of thing, Galveston or something like that. But yeah, this was obviously wiped out. I remember not too long ago, I think a hurricane hit Galveston, and they had a bunch of news stories about a house kind of similar to this. And literally, everything's wiped out. Most of these houses, you only see foundations left. Everything's gone. Everything's gone. But this house, like, doesn't even have a shingle missing. Like, it looks like it's perfectly fine. And the news story that I remember, I don't think it's that house, was that these people paid the Amish to come down and build like a super stout house, and the Amish built their like beach house right on the beach, and it survived a hurricane like it was nothing. Now, they're probably overbuilding it with really, really thick wood beams and all this extra stuff, but pretty interesting. If you want to build a hurricane-proof house, it probably won't work every time forever, but you can build them a lot better than a lot of the homes are built today. So just something to think about. Hurricane destruction, like I mentioned, the storm surge is a big deal. The storm surge is literally the water that's blown onto land as the hurricane comes up onto the land. So it's a large dome of water, 65 to 80 kilometers wide, that sweeps across the coast where the eye makes landfall, and it greatly contributes to your flooding, usually more than the actual rain itself. Wind damage is obviously a big deal. We saw the last picture, that was all wind damage. And then inland flooding from torrential rains. We saw that in Houston with Hurricane Harvey. Houston is not very far above sea level, and they do not have very good drainage. And so they had a lot of flooding in that city when Harvey just kind of sat over them for about a week. So what do we have over here? We've got a diagram. They're just kind of showing you the direction of movement of the hurricane, which is the white arrow, and then the rotation of the hurricane. And so they're kind of showing you on the backside, you usually have slightly higher winds because these arms are sweeping the same direction as the hurricane movement. Where on the backside here, they're kind of coming the opposite direction of the movement, and so they can be a little bit slower and not quite as devastating. So on this side, what do you have? 225 kilometer per hour winds. Over here, you have 125 kilometer per hour winds. So much, much faster on the kind of sweeping inward side. What do we have here? Tropical Storm Dean in 2007. They're just kind of showing you its path and how they predict the paths, I guess. But you'll see these pretty often when a hurricane's coming. We don't know exactly where it's going to go, but we have pretty good computers that try to predict that. I will say Iota this year, I think it was Iota, it went crazy and just like pinballed around the Caribbean and just went back and forth several times, I think, until it went all the way over, southern Mexico. So I think that was a pretty interesting one. I didn't see too much of it because it didn't affect us up in the United States, but that's where it is. And then the last slide. Why do hurricanes not form near the equator? Explain the lack of hurricanes in the southern Atlantic and eastern southern Pacific. The Coriolis effect. It's too weak at the equator to initiate that rotation, and so you don't really have anything form at the equator. It forms close to the equator because it needs that warm water, but not at the equator. And then the South Atlantic and Eastern South Pacific have too cold waters. There's not enough energy to support the hurricane formation and kind of feed it. So they don't see a lot of hurricanes forming there. Wonderful. That's it. We went through literally every single slide. Great job, everybody. Now, let me pass this out, and we will talk about the, what's it called? Signature assignment? Yes. Signature assignment. So we have maps, and we have questions. And you can go ahead and answer the questions on paper, but I think I'm going to ask everybody to, I still haven't made it yet, but I'm going to ask everybody to submit their answers on Canvas, because this is one of the things that I have to keep for several years, because somebody at the state or at Navarro could audit the class, and I have to produce these. Be like, yes, the students actually did them, and I gave them these grades, and here they are. So if they're on Canvas, that's much easier for me to be able to keep track of. And let's take a look at this. So this is not too bad. I've always kind of remembered this being pretty easy to go through. They ask you somewhat straightforward questions. You got to think about them a little bit, and I want you to give me short answers, not paragraphs, but probably 1 to 2 sentences, and try to be as detailed as you can. That's going to get you the most kind of points here. If I rotate this, it's not going to rotate the picture, is it? Is it? No. Well, that's okay. I can rotate the picture myself. I'm a grown up. But it's not here. I move it up. Yay. Just so we can see them, like y'all have them. And this one, the winds of the world. And you can go up to that other page. I skipped a page, but that's okay. Okay, well, it's not going to do that. So, oh, there we go. Yeah. Up a little bit. It's not great with the pen here. And this, we could just leave this right here where it's at. No big deal. So, what we have here are 4 maps. And you'll notice the first map is global surface currents. And what they mean by surface currents is obviously water. If the current lines don't go anywhere over land, it's going to be water. And so you have yours. Do not have color, unfortunately. We do not have a color printer in the school. Seems a little crazy, doesn't it? But to be fair, if we did have a color printer, every teacher would just go nuts with printing color all the time. And yeah, it'd cost them a lot of money. But still, we should have color printers, I think. I don't know. Maybe I'm just being crazy. But you do have red and blue lines. Maybe you can differentiate between those on your grayscale. If not, there will be a copy of this posted to Canvas. I just want to give you all a paper copy if that helps you out a little bit better. So we have red and blue lines indicating warm currents and cold currents. And they have the different types of currents named out. Obviously, we can see now that I was wrong the other day when I referred to the Gulf Stream as one of the air jet streams. The Gulf Stream is a water current, and Mr. Bailey should have known that. Somewhere deep down in here I did. But they have the different currents moving around, so this is going to help you with water current questions and water temperature questions. Here's another global current, and maybe a little bit more generalized. Looks a little bit more generalized. You have a little bit more detail in the top one, a little bit less detail in the bottom one. But I threw both of them in there because they were in my package of maps for this. This is going to be prevailing winds of the world. So this shows you what direction your winds blow in general, where they're blowing from, where they're blowing to. I will point out, not a lot going on in the United States, or at least our part of the United States as far as the winds. So you got to be a little bit imaginative. Like in the summer, where does our wind probably blow from? If we probably get wind from this little gyre here that's blowing up from the Gulf of Mexico into Texas. And where does it leave? It probably goes along this path to the eastern seaboard and out to the northern Atlantic Ocean. In the winter time, we're probably getting more of this wind pattern that's coming down from the central part of the continent, bringing us cold, dry air like we're getting today. And so kind of think about where we get our winds from the north and south during the winter and summer, and that will help you out a little bit on the maps here. The bottom one is, I believe, another example of that same thing, just very, very generalized, doesn't show you any continents, just kind of shows you the overall wind patterns. But there's one question that this will help out on quite a bit. I will point out they're going to ask you a couple questions. One about the horse latitudes. The horse latitudes are in both the northern and southern hemisphere. They also have them here. You're going to have to Google this and give me whatever answer you like best. But I Googled it yesterday again, not for the first time. And Wikipedia now, I don't know how long it's been up there, but Wikipedia now has 3 different answers for why these are called the horse latitudes. And I just want you to explain one of them to me. Pick your favorite one and explain it that way. There's one about them burning like a fake horse effigy as like a celebration of having paid off their debts. There's one that they're literally like throwing horses overboard because they're running out of water and the horses are dying, so they just throw them off the side of the ship. And then there's another one, which might be the most practical, but I don't know, that basically says that horse is like a sailing term, and they use that term the most in this part of the oceans. Just read through the 3 different explanations and give me one of the explanations as to why they call this the horse latitudes. There will also be a question about the doldrums. I think the doldrums are right here at the equator, so that's labeled on this map. So yeah, let's take a look at the questions and kind of get an idea of what they want from you. So it's not very long. It's 14 questions, not too bad. Short answer format. Make sure you're using complete sentences. Make sure you're giving me enough detail. Explain it to me like I'm an idiot and I don't really know what's going on. So I know that you know what's going on. It says to use map. You can look up other stuff. You don't have to just use these 4 maps that you have. But that being said, I think you can get a fairly sufficient answer from these 4 maps and a little bit of imagination and a little bit of understanding about the things that we went over this year. So number 1, look at the direction of the surface currents in the ocean and at the direction of the wind. So they want you to look at the ocean surface currents and the wind currents. What evidence do you find that wind influences the direction of surface currents in the ocean? So just compare them and see, are my surface currents moving kind of in the same direction as the wind currents? With my wind here, I see this clockwise rotation in the Atlantic Ocean in between the United States and Africa. If I go to my ocean currents, I see this similar clockwise rotation. And so that's the kind of thing we're looking for. Does it match up everywhere? Are there a couple places where it doesn't really match up? That's the kind of thing that I want you to kind of point out. You don't have to write like a whole paper on it or anything. Just give me a couple sentences. Let me know, do they correlate? Do they not correlate? And what do you think that means? And obviously we went over this year. Was that it? No. Obviously we went over this year about how waves and surface water currents are directly affected by the wind, so that should also help out a little bit. What pattern can you see in the direction of global winds from the North Pole to the South Pole? That's where your obviously the global winds one's going to help out, but the bottom one will help out a little bit more. But you can see everything up towards the North Pole is headed a certain direction. As you get below the horse latitudes and towards the equator, they're headed in a different direction. And then as you go further down to the South Pole, they move back in the other way. And so there's a definite pattern. And you can even see that down here on the bottom one. They do have the polar easterlies, which I think that other map does not have the polar easterlies. But you can see this pattern kind of forming as you move from the North Pole to the South Pole. So give me a description of that. Notice location and flow of warm and cold currents. What do you suppose the currents flowing towards? Why do you suppose the currents flowing towards the equator are generally cool, while currents flowing away from the equator are warm? So think about where your water is going to warm up at, and then where it's going to flow after it warms up, and kind of give me an explanation for that. And so this is just like a thinking assignment a little bit. Not too direct of questions. You're not going to be able to find like a perfect sentence in the book that describes these. But the book can help you. The maps can help you. And let's just see what else we have. What are the regions from which wind blows into your region? So this is us specifically. I mean, central United States, more specifically, if you can get it, Texas. Where do we get wind from? Where does our wind blow from into our region? And obviously, I want you to give me 2 different time frames. In the winter, our wind's blowing from a different direction than it is from the summer. What might the wind be bringing into your region? This is actually important. So I want temperatures, moisture, like right now in the winter, is bringing cold, moist air. Or not, sorry, it's not moist. Cold, dry air, because it's coming over the continent. And they even go a little bit step further. Where's that? Think about dust, insects, tiny seeds, smoke, air masses, cooler or warmer temperatures, and moisture. So anything else that you might think? If you're obviously it's cold outside, but if you're having allergy problems right now, could be a certain type of pollen that's blowing in from the central part of the continent. Just depends on what's going on. So give me a winter and a summer one, because those are 2 different wind directions that we're getting generally. There it is. When wind blows out of your region, so 4 and 5 are wind blowing into your region. 5 and 6 are stuff going out of our region. When wind blows out of your region, what region does it blow into? And so you should have a winter and a summer one for that as well. And so if it's blowing from the south, let me come back up to the wind. It's blowing from the south up into us, and you're getting warm, moist air during the summer from the Gulf of Mexico. Where does it go once it goes over Texas? It's going to continue to go up, maybe towards the east here, over New England, and then back out to the Atlantic Ocean, and maybe eventually over to Europe. In the wintertime, as it comes down, it's coming down and blowing into Texas from like the central part of the country, and really, who knows where it goes from there? Is it going to keep going down and go to the equator? Is it going to kind of curve back up and head back out to the Atlantic? You can make an argument for either one, but just kind of write it out in a sentence. Let me know what you think. Let's see. When water flows out of your region, what region does it flow into? This one, I want you to be a little bit more specific. I mean, our region is going to be Texas. We don't live on the beach. So our water has to flow somewhere. Where's it going to flow? First of all, like, where do all the Texas rivers flow into? And you can answer now. Where all the Texas rivers flow into? Into the Gulf. And then from there, where does the water from the Gulf of Mexico flow? That's going to be shown in one of the surface current areas. So the Gulf of Mexico is going to eventually enter into the Gulf Stream and kind of head up in this direction towards Europe. So give me a detail of that. Again, nothing too long, but let me know. And then let's see. How do the oceans of the coast of Washington, Oregon, and California affect their weather/climate? Obviously, the water over there is going to be cold. The water on the western side of continents is generally cold because you have upwelling. So let me know what you think that kind of affects their weather and climate. And this is going to be one you're probably going to need to Google. I don't know that you're going to find a great explanation in the book for this. But you can think about it, kind of give a good explanation. Maybe Google it to make sure that you're right. But there's a direct relation between, especially like Washington and Oregon, and their overall weather to the fact that they're right next to the Pacific Ocean right there. What might be the weather climate effects of eastern Brazil due to ocean currents and prevailing winds? So find out eastern Brazil, find it on the maps, look at which direction the winds and the ocean currents are flowing. You can see eastern Brazil is going to be right here. If you don't know this, Brazil is the big country in South America. And so they're getting winds coming right up here from the warm part of the ocean. And if you go up to the ocean currents, they have this warm gyre right here kind of circling around towards the coast of Brazil. So that should help you kind of get an idea of what kind of climate they should have, even if you've never been to Brazil or heard of Brazil. Explain why England has such a cool, wet climate. Same thing as you're doing with Brazil. Look at the winds and the water currents and kind of explain why England's so cold and rainy all the time. At what latitudes are the doldrums located around the globe? And maybe even give me just a short sentence on why they call them the doldrums. It's easy. You can Google it. And then same thing, Google the horse latitudes. What is that name from? That's actually probably a terrible sentence. Why do they have that name? I'll change these before I put them up on Canvas. Number 13, why do you suppose the summers in the northwestern U.S. are so different from the summers in the northeastern U.S.? You got to look at where they're getting their wind from. What's happening? Where's that wind coming from for the northwest and for the northeast? And why is it so different? Explain how and why Southern America's weather and climate is so different from Eastern South America. Consider their currents and winds, and give me a little explanation for that. So it's just like a weather analyzing kind of assignment. Once you kind of get rolling on it and get used to looking at the maps, it should kind of flow pretty easily. If you have questions, ask me or email me. We have today's class period, tomorrow's class period, and if you get done, you can turn it in and I'll start grading them. To be honest, you're going to have the weekend and try to turn it in Monday. But next week is finals week. We've got a lot of stuff to do, so do try to get this done this weekend if you don't already have it done by the end of the day, Friday, and get it turned in Monday. So wonderful. Any questions? I will post the colored maps on Canvas right now because you cannot really see the difference between the red and the blue. All right.